Good morning. Myself Sivakumar, Assistant Professor, CSC Department, Vignesh Nirula. So today topic is Unit 1, Distributed Systems. That is Characterization of Distributed Systems and System Models. So we will discuss the first topic today, that is the Characterization of Distributed Systems. So in characterization of distributed systems, there are four topics. One is introduction to the distributed systems, and second one is examples of the distributed systems. The third one is resource sharing on the web, and fourth one is challenges. So we will discuss one by one. So this is the textbook which we are following. That is Distributed Systems Concepts and Design by George Coleridge, Jean Dollimore, and Tim Kindberg. Okay, and edition 4 is the prescribed syllabus for our university. Okay, so what is a distributed? Now we will see the definition of the distributed system. So what is a distributed system? A distributed system is a distributed network computers where each component in the network computers can coordinate and communicate each other by passing messages. So that is the definition of the distributed system. So here, if you see here, what is a network computer? So a network computer is either it could be a home network, factory network, or a hi-fi network. Okay, so like that, those are all come under category of network computers. And what is the goal of the distributed system? So the goal of the the primary motivation for distributed system is to share the resources. What is meant by sharing? Sharing means accessing the resource or providing a resource, okay, to the clients. Okay, that is the purpose of that is the goal of the distributed systems. And what are the issues associated with the distributed system? So that we will study. So first one is concurrent execution of process, and second one is no global clock for coordination, and third one is more components and more independent failures. So what is meant by concurrent execution of process? So the distributed system, the concurrency is the main concern here, because more than one system will present in the distributed system, and each can communicate, each can provide a resource so that everyone has the access to the resource. Okay, so the concurrent execution of the process. Okay, that is about the first one. And second one is no global clock for coordination, because in a system, in a distributed system, what happens is there are sequence of actions going on. So how to determine which action is happened and what in what order? So that is nothing but according to the time. But here there is a lack of accuracy in the each time provided by the different systems in the distributed system. So that means there is no common clock across the world. So some countries prefer UTC, and some countries GMT, and India prefer IST. So like that, there is no common time. So how to synchronize them? So the only way to synchronize is by passing messages. So that is there in the definition itself. So there is no global notion of time. That is one of the issue in the distributed system, and we can overcome this issue by simply passing messages between the distributed system. So that is the second one. That is no global clock for coordination. We will use message passing mechanisms. And third one is more component, more independent failures. That means independence of the failure. That means whenever a component fails, so what happens is it will not stop the entire system. So that means it will stop, but the remaining system will be inactive, and the actual purpose can be done by the remaining system. So that means isolation. Only that system will get affected, and the remaining system fault tolerant, we can say. So that means that is one of the characteristics of the distributed system. So fault tolerance, concurrency, and global clock. No global clock. Okay, so these are the three issues. Okay, in the distributed system. Next is, what are the examples of the distributed system? So we in the textbook they are given 3 to 4 examples. So these are the different examples of distributed. One is global internet, and second one is intranet, and third one is mobile computing and ubiquitous computing, and there are several issues here which we have to study. So first one is global internet. So what is meant by global internet? So what is the internet? So internet is a vast collection of computer networks. Okay, so that is the definition of the internet. So internet also forms the distributed system. Okay, and intranet. So intranet is part of the internet, will become the intranet. So here what we consider is where there is a necessity of router and firewall, because the internal network configuration is being done by the organization itself. Okay, organization itself. And here the configuration is required. Why? Because to provide security. Because firewall is an example where we ensure security in distributed system for a intranet. Why? Because, and what is the purpose of router? So router is intranet is connected to computers via routers. Okay, intranet is connected via router. So there may be LAN in the intranet. Okay, there may be LAN, and several LANs are connected by routers. Okay, so how the routers are connected to the internet again. Okay, so like that, the entire system is actually organized in the form of a distributed system. So this is another example. And we study firewall here. So firewall is providing a security mechanism. That means it will filter the incoming and outgoing messages. How it will filter is based upon the source or destination. So based upon source or destination, it will simply filter the message. Filter the message. So that is about the firewall. And mobile and ubiquitous computing. So mobile computing. So mobile computing means computers on move. Okay. So like that. So the user has access to the home environment, and when he move to another environment, okay, so still has access to the home environment. So that is how it's possible, means by the mobile computing. Okay, so user has access to anywhere. And next is ubiquitous computing. That means computers embedded everywhere. Ubiquitous computing. That means it is fixed in its location. Okay, and but still it will provide the access to the home internet. So that is possible using ubiquitous computing. And what are discovered resources in different host environment? That is one issue in this distributed system. And second is dynamic reconfiguration. That means the system may change. Distributed system is open-ended. That means any system can be added to this distributed system and can be removed from this distribution. That's why it is called as a dynamic reconfiguration. And limited connectivity. That means we cannot. That means limited connectivity. So that is another issue here. And privacy and security guarantee to the user and the host environment. So user environment is where the user present. Host environment is where when the user present in other environment. So in both the cases, privacy and security guarantee is also one of the concerns in the distributed system. So this is an example of a internet. So internet means interconnection of connection of networking. Okay. So here, if you see here in the internet, so here in the internet, ISP means Internet Service Provider. So this is the actual internet connection is provided by these ISPs. Okay, and intranet. Internet connection of intranet and satellite links. This is a satellite link. And this is a backbone. What is a backbone? A backbone is a high capacity link, okay, which consists of it's a high capacity link, so which consists of transmission lines and satellite links, okay, like this. And here this is a computer and these are servers. Computers and servers. So what is a server? A server is one which responds to the which gives response to the request given by the client. So that is nothing but a server here. Okay, so this is basically the internet structure. So which consists of satellite links, network links, which consists of satellite link. This is a network link. This is a network link. So network link connects the intranets, and the satellite link is a link used to connect with the satellite so the satellite link is provided by the internet service providers. Okay, with the system. And the backbone. So backbone is nothing but a connection of these satellite links and the it's a high capacity link, so which is used to connect between the internets. So this is about the internet service provider. So this is intranet and internet service provider. These are the terms. So internet service provider which provides the actual internet to the system. So where we can do the emailing and web access. So all those things will be given by this internet service provider. Okay. Next is intranet. So here internet and intranet. So intranet means where actually local area network. So this is a local area network. Again, this is a local area network. Local area networks are connected, and there are different services available: email server, web server, print server, file server. And there is a router where actually we connect to the internet. So using router, we can connect to the internet from the intranet. Through routers, we can connect to the internet. And these are other servers, print server. So print server is again a service. So print server provides the print service. Email server provides the email service. File server provides the file service. So these are different services provided by the internet. Okay, email server provides the email service. These are the desktop computers. Okay, so this is about the typical intranet. So intranet is connection of LAN. LAN is nothing but a local area network where we connect to internet through the routers. Or what is a firewall? A firewall is again a security mechanism which is used to filter the incoming and outgoing messages based upon the source or the destination. So here, the important thing. So what is intranet definition? Intranet is a part of a internet. It is a part of the internet. So which is used for the purpose of which is also an example of a distributed system. Okay, this is about the next portable and handheld devices. So what are these? So portable and handheld devices. So for example here, if you see, this is a mobile phone. This is a WAP, that is wireless application protocol. Home intranet, internet, host intranet. So two intranets and internet. Okay, so this is an example. So where the user can on the move. So from here, from digital camera, he can send the photo. He can send the photo to the host intranet. So he can send the photo while he is in a meeting. He can send the photo to the host intranet. Okay, that is one thing we can note down. Okay, or using mobile phone, he can access the mails and he can through wireless application and connect to the internet and can access the mails and he can access the mails. So that is another example we can find. So he can access the mails, or he can take the photo and can send to the team. in meeting. Okay, so like that. So basically here what happens is in internet. So here we can study that. We can also study that in distributed systems, whether it is internet or intranet. So in case of internet, so what happens is we can use the video conferencing also as for distributed system, but it is not full-fledged. It is limited. It is limited. So that is what here. So we can take an example here. So using camera, we can send the photos to the host internet, or using mobile phone, we can send we can check the mails and respond to the mails by connecting to the internet. Okay, so this is another example. So user has a feeling that he can connect it to the host environment as well as the home environment. Okay, from home environment user can connect to internet, or from the host intranet he can connect it to the internet. So whenever you connect it to the intranet, so it immediately get connected to the internet. Okay, so that is how we can see in this example. Okay, so basically if you see the last 3 slides, that is about the examples of the distributed system. So basically we have noted down that, so in case of internet, intranet and mobile and ubiquitous computing. So because of the technological advances in the device miniaturization, so now we are using several types of devices, like wearable devices, handheld devices. Wearable devices examples are smartwatches, and handheld devices examples are mobile phones. And so we are using because of the technology advance, we are using these type of devices in case of mobile and ubiquitous computing. Okay, so that is also we have discussed. We are discussing the last part, that is examples of the distributed system. Okay, so this is about the examples of the distributed system, and here we will discuss now about the resource sharing and the web. So what is resource sharing and web? So here it consists of 3 main parts. One is HTML. So basically resource sharing and web in context of HTML, URL, HTTP. HTML, URL and HTTP. Okay, so what is HTML? HTML is nothing but the hypertext markup language. So it's a programming language. And URL is nothing but uniform resource locator. URL is nothing but the uniform resource locator. And example is HTTP : server name, port, path, arguments. So here we can see that, so server name is compulsory, if you see here, whereas port, path name and arguments are optional. Okay, so port is by default 80 for HTTP, and the path name and arguments are, it differs. Suppose if the URL is like this, http://www.cdk4.net/ search Kinberg. Okay, so this question mark is present here. Okay, and suppose path name is required, for example like this, http www.google.com/examples/ so here slash we are given here, so that means this examples is now a path. Example nothing but a path. So :port is optional. So this is about the uniform resource locator. That means what is this www.cdk4.net? This is nothing but the server name. Okay, and this is arguments, and this is path. and the entire thing is URL. Uniform resource locator, uniform resource identifier. So we can call both it, but here URL is the most frequently used term, so that's why it is called as a URL. Okay, so every suppose if these are not present, only CDK4 is present, only server name is present. So in that case, only server name is present, so that will become the default. CDK4.net. Okay, so that means this is the default name. So default is nothing but the server name. Server name. Okay, and what is this HTML? HTML and how it will works. So it will works basically by since the HTML language tags P. Okay, so like this. P/P. So these are nothing but the tags. Okay, suppose if you want to include a hyperreference, so hey href, give the link, and here end the tag and give the tag. Okay, and give here moon. Okay, and give in href, that means hyperlink reference, give some link. So http www.google.com/moon.html. So that we can give in the place of href, that is hyperlink reference. Okay, so this is about the HTML. So HTML is basically a programming language which works based upon the tags. P is for print, paragraph. Okay, can print. So whatever the matter you will give in between this, so it will be in the form of a paragraphs. Okay, next is HTTP. Next is what? HTTP. So what is meant by this HTTP? HTTP is Hypertext Transfer Protocol. So this is again a protocol. So it will work based upon the request reply, that is client server. So here client is there, server is there, client send a request and server reply back to the client. So client send a request to the server and server reply back to the client. So this is what basically the HTTP Hypertext Transfer Protocol. Okay, so this is nothing but a request reply. So they send request to the server and reply. So this is nothing but a process. A client is actually client and server machines in general terms, but in distributed systems, client is a process and server is a process. And a server can also act as a client for can also act as a client. And that means a process can act both as a client and server also. So what is meant by invocation? Invocation is nothing but, suppose you want to what is meant by remote invocation? So remote invocation means sending a request to the server and getting back the response from the server. So the entire thing is nothing but the remote invocation. Remote invocation is nothing but sending a request to the server and getting the reply from the server. Sending a request to the server from the client and getting a response from the server is nothing but the remote invocation. Another important term, remote invocation. Remote invocation. Next is content types, MIME types. What is meant by MIME and why we are concerned here MIME content types? Because this is another important point to discuss here. So content type. So normally what happens is we send a request. So we will send a request to the server and server responds to the again send a response to the browser, and browser renders the text. Rendering is happening at the browser. Okay, so server only gives the location. Suppose http://. Okay, I given one server name, so google.com. So it will search in the server google.com and in the particular location examples, and then it will pick the file from there. Okay, it will only what happens is the actual content very actual, so that will be find it out at the server side. But which type of, so whether it is a zip, application.zip, or whether it is a image/GIF, or whether it is a text by HTML. So this is decided. So only the type of the application. This is nothing but the MIME type. So MIME is nothing but the images, multi-purpose internet mail extensions. Okay. So this content type is determined by the system only, server only. So it will pass it to the browser for rendering. So browser will render the text. So if it is an image of GIF format, so it will simply renders the image, renders the text. If it is a text by HTML, if it is of type only GIF, that means only GIF is supported by the browser. Suppose if it is a JPEG, then here it is image/JPEG. Information is passed to the browser by the server. Okay, so like this, the different types are also decided by this. Next is one resource per request. This is another important point. So one resource per request. That means this resource sharing and web, that is in the context of www, which we are studying now, World Wide Web. So here one resource per request. So only one resource will be initiated. Suppose there are 9 images, and then in that case 10 requests will be sent to the server. Okay. So that means only one request for the, so total 10 requests will be sent to the server. Okay. Simple access control. So this is another important point here, resource sharing in the web. Okay. So here we have seen that. So what is web is discovered by Berners-Lee, internet. So in 1989. Okay, so in Switzerland, in CERN, CERN is nothing but a European Center for Nuclear Research. So they actually used this for the purpose of sharing the files across the sharing the files and documents. So, but later it is evolved and evolved as www. Okay, so that's it regarding this. Resource sharing on the web. So this is example which we have told just now. So this is a request. So this is a request which along in the internet. So we posted a request. http://www.google.com/search $Q equal to Kinderberg. Okay, so in this case, or else here, so there is a table. There is a table, path name, and here query or search. Okay, so for this example, DNS name, that is server name. In this example it is www.w3c.org. So this is the DNS name, and the path name is protocols/activity.html. activity.html, and there is no query, none. This is number 1. And in this case, for the second one, here the server name is www.google.com, and path name is, there is no path here, only query is there, that is Kindberg. So these are the two examples which how the actual mapping will happen. So DNS is a domain name server. So so that contains the lookup table. So that lookup table contains the server name and the IP address corresponding to it. Server name and the IP address corresponding to it. So this is about. So this table is maintained in the maintained across this server. Okay. So in that server www.google.com, in that server, search for the Kindberg. In the server w3c.org, look for protocols and then look for the activity.html. Okay, so how these file is, how this how these files are published. So locally there is normally public underscore HTML is the directory which we will use. So for publishing the resources, so that way we can HTML files are published in public underscore HTML. Other web technologies. So what are the other web technologies associated with the system? That is web form. So first one is web form. So what is a web form? So a web form is again a web page, a HTML page. So where we provide the input to the form. We provide the input to the form and we will finally submit the form and you will get the response from the form. So that is nothing but a web form. So for example, it contains widgets, that is text box, so where we can actually do the enter the data. Okay, so that is nothing but a web form. Okay, and so here we can discuss like this. So web form are very important in the case of where user sends the for example, user enters the information. Okay, so while doing a financial transaction, so you can enter the credit card information. Okay, that is sensitive information. So web forms are, and also we can do validation using JavaScript. So here, what are the there are certain types of codes which are executed the browser. Okay, for example, applet. So applet is where it will execute in the browser. Okay, that is one example. And another example is JavaScript. So instead of doing validation at the server, what we are doing is we are doing the validation at the client side and pass the information to the server. So that is about the code, mobile code. So we can mobile code, examples of mobile code are Java applets, and so you can see here web form. So that means we can input the data in the form of a web and we can send across the system using HTML. So second one is CGI programs. What is the second category? That is common gateway interface. So a CGI is a program which runs at the server. Okay, and it will send the response back to the client. Okay, so that is about the CGI, the common gateway interface. So it is required in order to execute the programs at the server side. Okay, so that means we pass the parameters required from the client to the server and we perform the execution at the server and response back from the server to the client. So that will happen using CGI programs. So another example where I told you, so the applets, a client. So client example is browser. Okay, so applets are the programs which run at the client side, that is in the browser. Okay, so that means we can do the validation using JavaScript, where we can run the Java programs, applets in the, but there is a potential harm with the applets because security concerns are there. Okay, whatever the program you receive in the form of email attachments, so if you run those programs, so what happens, there is a potential threat to the system. Okay, so that we have to look into. Next is RDF, that is Resource Description Framework. Okay, Resource Description Framework. So this is another terminology. Next is Extensible Markup Language. Extensible markup allows metadata to be included. Metadata information to be included. XML. What is the difference between HTML and XML? So XML is a structured specific and format. Okay, that is normally extensible. So definition is extensible markup language. The difference between HTML and XML is HTML is only for present. We cannot store the data here. Whereas in XML we can store the data also. Okay, that is another difference between HTML and XML. So this is about the various other web technologies. Okay, web forms, applets, CGI, RDF and XML. So now we will see the different issues with different challenges in the distributed system. So as we know, distributed system is open to the internet. So what happens is there are several challenges here. Heterogeneity is one of the challenges. What is meant by heterogeneity? Heterogeneity is nothing but differences in the systems, in the components in the distributed system. For example, different operating systems are there, different programming languages are there. Okay, and another difference is different architectures are there. For example, some are little Indian, some are big Indian. So those are the differences. Okay, so like that, heterogeneity is one of the challenge in the distributed system. Okay, and here this figure is corresponding to the scalability. So scalability is also one of the challenge in the distribution. What is meant by scalability means the number of users increases in the system. So, but still the system can support. Remember the scalability. In 1979 there are 188 computers and 0 web servers. Whereas in 1989 there are 1,30,000 computers, 0 web servers. Okay, and 1999 in July 50. Here the number is 56,218,000. So this is another improvement. I mean, day by day the number of users are increasing, the number of computers and web servers are increasing. Computers and web servers are increasing. Okay, so this is about the regarding the scalability issue in the distributed system. Okay. లేదు అక్కడ ఉంది వాళ్ళ దగ్గర నేను తెచ్చుకున్నాను స్లాట్ 11:31 11:15 11:30. Okay, so this is so the issue here is scalability. So scalability is nothing but number of components connected to the system. So that is nothing but the scalability. So as the number of users increases, still the distribution will support the features 8 provides. That means basically the resource sharing. So what are the resources it should have? So that should be made available to each and every user. Okay, so that is about the. So if you see the figures, they're drastically increasing in distributed system. Okay, so these, I mean, we can also see in normal terms, that is in computer networks. Now IPv6 is coming, so IPv4 is gone because of the improvements in number of networks. Okay, number of computers and classification also change. So scalability is one issue. Okay, so initially there is a 0.08, that is 0.08%. Now 0.4%, 6% total and 25% in 2001 July. Okay, so this is about the computers versus web servers. So see the heterogeneity. So as I already pointed out, here first thing is networks, hardware and languages. Hardware I told you, there are different hardware, little Indian and big Indian. Okay, and networks, there are differences in networks also. So that is another issue. And languages, programming languages, OS. Okay, that also makes a difference. Unix programming language, Java is machine independent, whereas remaining programming languages are not. Because Java produces the bytecode. So that's why we can execute a program on any machine when you write it in Java. But the same thing does not happen with other systems. Okay, difference in middleware, Corba. Middleware. So middleware means it is also a software which is required to negotiate the differences. Okay, Corba is an example, the common object request broker architecture. Okay, so this is another example, and RPC also, RMI also, these are different middlewares. Okay, code, not only code, but RPC, RMS. Mobile code and virtual machines. As I told you, mobile code example is Java applets. Mobile code. Okay, that means, so these are the heterogeneity in the distributed system. That means not only same but also different systems in here. Okay, that is the first one. Second one is openness. Second one is what? Openness. That means distributed system should be open to the. That means we can add systems to the system and we can add many systems to the distributed system. We can remove these systems from the distributed system. Okay, there is nothing but the. So this is the task of the designer. Designer to even though if you have any fault in it, then it should extend the system. Extend the distributed system. Okay, standard published interfaces and RFC. So RFC means for every technology, so we will have RFC. For every technology we have RFC. So that means request for comments. So every technology, for example, Bluetooth, it has specific number. Okay. For example, wireless LANs. So 802.11. So like that, for every RF, for every network component we have RFC associated with it. Okay, so we need to add RFC also. Next is security. So with regard to security, confidentiality, integrity and availability. Confidentiality, integrity and availability. So confidentiality, only authorized users is allowed to access. Integrity, suppose if there is any, no one in the system can alter or change the messages which we pass. Availability, suppose if any component in the distributed system fails, then we should have given access to remain. The system remains stable even though there is a fault in a single system. The system should be isolated and the remaining system should function as usual. So this is about the availability. Okay. Okay, and in virtual machines, I told you the best example is Java virtual machine. So Java is another example where we have Java virtual machine. So where the information is passed in the form of bytecode. Okay, so with and that is independent of the platform. Okay. Next is scalability. So scalability. Just now we have seen the examples of scalability. So how the computers and web servers are evolved from 1979 to 2003 and 2004. So this is nothing but the scalability. So a significant increase in resources, still the system should support the. So normally we will face situations in railway reservation. So always slow down. So we have to avoid the situation. Okay, we slow down the network. So slow down the connection. So whenever we try to book a ticket. So how to avoid that one? So we will see in the distributed system. So that is applicable, one of the applications in the distributed system. Increase the resources. Increase the resources. That is one of them. Cost and performance also taken into consideration in scalability. It should not beyond the cost and it should not beyond the performance. And failure handling. When a system fails, so what happens? What are different types of failures in distributed system? Okay, so that comes under failure handling. For example, a system may crash. A message may not reach the destination. So retransmission. Okay, that is what normally we will do. Okay, so like that, there is no response from the server. So what will happen? So like you have to detect the fault first, and then masking, that is hide or less severe. Tolerating, ignore or timeout, and recovery is possible through logs and rollback. And finally, redundancy means without knowing the user, we put a replicas of the data and finally access the data. Okay, there is nothing but the redundancy. And finally, we will see about the concurrency. So concurrency is also an issue in distributed systems. So what type of measures you will take? Synchronization, semaphores. So that is also possible in distributed systems. So concurrency of processes. Okay. So when more than one process simultaneously execute for example, stock, for example, if you want to bid, okay, X bid 112 and Y bid 111. So if there is no concurrency, what happens? So X will be bidded as 111 and Y will be 122. Okay, 122. So there is so that's why. So concurrency is very important whenever in a distributed system. So there are certain measures which we can take for ensuring concurrency in distributed system. One such example is semaphores. Using semaphores. Okay, so that is also a subject of study. Next is transparency. So this is very important topic in one of the important challenges in the distributed system. That is transparency. Transparency. So totally there are access transparency, 8 transparencies are there in distributed system. Access transparency, location transparency, concurrency transparency, replication transparency. Okay, so we will see for what is access transparency. So access transparency refers to accessing a resource. So we can enable either local or remote. So either both of the resources can be accessed. So that is nothing but the access transparency. We can either access local or remote resource with the same set of operations. Second one is location transparency. What is the second one? Location transparency. That means irrespective of the location, whether the resource is present locally or remotely, okay, we should access the resource. That is location transparency. Concurrency transparency. So enable several processes to operate concurrently using shared resource without interference between them. Example is bidding. Okay, so that is so we can bid with one person may bid with 100 rupees, another person may bid with 200 rupees. So it should not that first person bid with 200 and second person bid with 100. Okay, it should not interfere. So there is another. So that is also required in distributed system. And then next is replication transparency. So enable multiple instances of resources to be used to increase the reliability and performance. So when you say a performance, when it works even in worst case scenarios, that is even when a system is failed, but still you will get the output from the distributed system. So in that case, we call how it happens is by using replicas. Without knowledge of replicas or application programmers. So inside what happens is there is a replicas present without the knowledge of the user, and using those replicas we can achieve this replication transparency. Okay, that is about the replication. Next is failure transparency. So that means what happens when one of the component in the distributed system fails. So that is about concealment of the failures. That means even though failure exists, we didn't know that the failure is actually occurred. So allowing users and application to complete their task despite of the failure of the hardware or software components. A distribution is nothing but not only software but also hardware component. Even hardware component fails, the system will work as intended. Next is mobility transparency. That means movement of resources and clients within a system without affecting the operation of the users or programs. So mobility transparency, when you move on, so suppose you take a laptop and you move on to some other location, okay, from home to office, and then you connect and then you will work it, so it will still work. It should still work. You should have access to the emails, files, databases, data objects, so whatever you do. So that is possible because of mobility transparency. And seventh is performance transparency. That means enable system to reconfigure to improve performance as loads vary. Okay, that is also performance is one of the important concern in distributed systems, because as the load increases, so how a load is shared, so it will share with the remaining peers in the distributed system. Okay, so that's why. So performance is also one of the performance transparency also. Next is scaling transparency. That means allow system ability to expand, scale without change to the system structure or the application algorithm. So these are the 8 transparencies in the the 8 challenges in the challenges of the distributed system, that is transparency. These are 8 types of transparencies in the distributed system. Okay, so we will discuss in the next class.